This is the Math 6 7.5 to 7.7 quiz review. Feel free to pause this video whenever you want or re-listen to any sections, maybe more explanations that you need help with. But if you'd like to pause the video before I go through each problem and then check with my work or follow along, either one is fine. So let's get started. The first slide says to write the word sentence as an inequality. So this is back to 7.5. We're going to be given a word sentence and we're going to have to identify the phrase that we could replace with an inequality sign and then write that inequality. So we are given a number x is greater than 0. So right away I see greater than. I'm going to underline that phrase, and I know that means the greater than symbol. We're given the variable x, so I'm going to write this as x is greater than 0. Our next problem says twice a number c is at least -8. So here I think at least. And when I hear at least, I think, well, that's the minimum. But it could be -8. So at least I think greater than or equal to. Twice a number c. Now that also tells us an operation and what we're doing in that operation. So twice is multiplying by 2. So we're going to twice c, or multiply c by 2. So I'm going to put 2c is at least, which is greater than or equal to -8. Our next slide says to tell whether the given value is a solution of the inequality. So again, this should seem somewhat familiar. We're given a value. We have to plug that value in where we see it, or we see the variable, and then check to see does the left side and the right side agree. So on this one, since it's inequalities, it's a little bit different than equations. We're given the inequality 2n is greater than 16, and we're checking to see if 9 is a solution for n. So what we do is we plug in 9 for n, so 2 multiplied by 9 is greater than 16. The product of 2 and 9 is 18, and I have to decide, okay, is 18 greater than 16? Yes, it is, so this is a solution. Our next problem says x minus 1 is less than or equal to 9. And here we're checking to see if 10 is the solution for x. So again, we're going to plug in that value for x. So 10 minus 1 is less than or equal to 9. So the difference of 10 and 1 is 9 is less than or equal to 9. So we have to decide, is 9 less than or equal to 9? Well, 9 is not less than 9, but it is equal to 9. So this as well is a solution, so yes. Our next slide says to graph the inequality on a number line. So we're not going to be solving anything. All we're going to be doing is taking the inequality that we're given and put it on a number line. So our first problem says that y is greater than -4. So I'm going to draw a number line. I'm going to put 0 in the middle. I'm going to put -4. And then I'm going to put 4, its opposite, on the number line as well, so I can see where the negatives and the positives are located on the number line. And we're going to graph on -4. So y is greater than -4. So since we have that greater than symbol, we know it should be an open circle. And then we have to think of a value that I could plug in for y that makes it true. So on this, I'm going to pick 0. I know that 0 is greater than -4, so I'm going to point my arrow in the direction where 0 is located. The next problem says m is less than or equal to 3/5. So even though this is a fraction, I'm still going to just put 3/5 and its opposite, -3/5, on a number line. Now here we have m is less than or equal to 3/5. So because that or equal to is there, we can put a solid circle on 3/5. And then I have to think of a number that again makes this true. So I'm going to pick 0 again. 0 is less than or equal to 3/5, so I'm going to point my arrow to the left towards 0 on that number line. The next slide says to solve the inequality and graph your solution. So we're going to do 2 steps here. We're going to solve it first, then we're going to put that solution, or those solutions, on a number line. So here we have x plus 4 is less than or equal to 8. I'm going to first draw my railroad tracks, and I'm going to treat this like I'd be solving a one-step equation. So this is an addition problem. So we have to use the inverse operation of addition, which in this case is subtraction. So we're going to subtract 4 from the left side and 4 from the right side. Whatever you do to one side, you have to do to the other. So those 4's cancel out, and we're left with x is less than or equal to 4. So that's our first step, solving that inequality. Now we're going to put it on a number line. So I'm going to put 0, 4, and then -4, the opposite of 4. And here it's less than or equal to. So I'm going to put a solid circle on 4. And then I'm going to think of a value that makes this inequality true. And the first thing that pops into my head is 2. 2 is less than or equal to 4, and 2 is to the left of 4 on this number line. So I'm going to point my arrow to the left. Our second problem says 18 is greater than 16 plus g. So again, this one is an addition problem. The only difference here between the first one and the second one is that our variable is no longer on the left side. It's on the right side, which is fine. We're still going to do the exact same steps we would. So since this is an addition problem, we're going to use subtraction to solve it. And we want to get g all alone. We want to isolate that variable. So we're going to get rid of 16 on the right side and 16 on the left side. And I'm left with just g on the right side. 18 minus 16, or the difference of 18 and 16, gives me 2. So I have 2 is greater than g. So I'm going to put this on a number line. I'm going to put 0, 2, -1, -2, and I'm going to go to 2. Since this is a greater than symbol, g cannot be 2, so we're going to put an open circle on 2. And now I have to think of something that makes this inequality true. So 2 is greater than what number? And here, the first thing that comes into my head, well, 2 is greater than 0, so I'm going to point my arrow towards 0 on a number line, which here is to the left. So remember, we have to draw railroad tracks, show the step of work, so whatever we're doing on one side of the inequality, we have to do to the other. We're going to have our inequality and then graph that on the number line. And make sure you're careful if it's supposed to be an open circle or a closed circle. And the best way to tell which way to point your arrow is come up with a number that makes your inequality true. And from there, then you point your arrow towards that number on the number line. Our next slide says to write the word sentence as an inequality, then solve it. So we're going to be given a sentence here, and then from that we're going to write the inequality and then solve it. So we have 2 less than a number is more than 15. So I'm going to say this is a number x, just so we have a variable. So 2 less than a number x is more than 15. So more than already tells me it's going to be a greater than symbol, and we already have that 15 there. So we know something is more than 15. It says 2 less than a number. So less than here means subtraction, and we want 2 less than x. So we have x and we want 2 less than it. We want to take 2 away. So here this is x minus 2 is greater than 15. So from here, we're going to solve this inequality. It says nothing about graphing, so we're just going to write it and solve it. So here this is a subtraction problem. We're going to use the inverse operation, which is addition. And we're going to add 2 to both sides. And I'm left with x is greater than 17. And I'm done with that problem. Our next one says 7 more than a number is less than or equal to 27. So less than or equal to is actually the name of our symbol, less than or equal to. And we know something is less than or equal to 27. So 7 more than a number is less than or equal to 27. Again, I'm going to put a number x just so we have that variable. You can pick any variable you want if you're not given one. Normally you'll be given one, but in these cases I'm just coming up with x since it's the most common variable. More than means addition. So we want 7 more than a number x. So we're going to add 7 and x together. I'm going to write x plus 7. 7 plus x also is okay. And then I'm going to solve this inequality. Since this is an addition problem, we're going to subtract 7 from both sides to get x alone, to isolate that variable. The difference of 27 and 7 is 20. So we have x is less than or equal to 20. Okay, now we're moving on to solving the inequalities again and graphing our solutions, but these are going to be multiplication and division problems. So our first one is 121 is greater than or equal to 11s. So I'm going to draw my railroad tracks, and 11s, since those are next to each other, that coefficient and that variable, the coefficient being the 11, the variable being the s, since they are next to each other, that's multiplication. So we're going to use the inverse operation, which is division, and we're going to divide both sides. And in order to get s all alone, we're going to have to divide by 11. So we're going to divide both sides by 11. 11 over 11 gives me 1, or just 1s. Bring down that inequality sign. And 121 divided by 11 is 11. So I have 11 is greater than or equal to s. Again, our variable's on the right side, which makes things sometimes a little trickier. So we really have to be careful of what number we choose to make the inequality true when we're deciding which way to point our arrow. So again, I'm going to put 0 in the middle, 11 to the right, negative 11 to the left. And since this is a greater than or equal to symbol, I'm going to put a solid circle on 11 because s can be 11. And now I have to think of a number that makes this inequality true. So what number, or 11 is greater than or equal to what number? So I think, well, 11 is greater than 0. So I'm going to point my arrow towards the left and point it towards 0. Our next problem, 3a over 2 is less than 24. So this one's a little bit different. What we're going to do here is actually rewrite this as 3 halves a is less than 24. Both mean the same thing, but here then we can actually see the coefficient clearer. So what we're going to do here is we're actually going to multiply by the reciprocal of that coefficient. And remember, the reciprocal is when we flip-flop that fraction. So the reciprocal of 3 halves is 2/3. So we're going to multiply both sides by 2/3. These 2's on the left, they cross-cancel into 1. These 3's cross-cancel to 1. So we're left with just one single a. And a is less than. Now I'm going to multiply 24 by 2/3. And I'm going to think about this as like 24 over 1. And when I look at this problem, I see I'm multiplying fractions. So I'm going to look first to see if I can simplify by cross-canceling instead of just multiplying straight across. And I notice that 24 and 3 have a common factor of 3. So I can divide both of them by 3. 3 divided by 3 gives me 1. 24 divided by 3 gives me 8. And I'm left with 8 over 1 multiplied by 2 over 1, which is just 8 multiplied by 2, which gives us 16. So I have a is less than 16. And I'm going to put this on a number line as well. 16 on the right, negative 16 on the left. Since this is just a less than sign, a cannot be 16. So I have to put an open circle on 16. Then I have to think of a number that makes this inequality true. I think, well, 0 is less than 16. So again, I'm going to point my arrow to the left towards 0. Our next slide says write the word sentence as an inequality, then solve the inequality. So I have 3 times the number x is more than 18. So again, I see this more than, I think a greater than symbol. 3 times a number x means multiplying by 3. So I have 3x is greater than 18. And I'm going to solve this inequality. Since this is a multiplication problem, I'm going to use division. And I'm going to divide both sides by 3. I'm left with x on the left side. And then on our right side, I'm dividing 18 by 3, and I get 6. So I have x is greater than 6. Again, my directions don't say to plot or graph this, so I'm not going to graph it.